Hi there! This is the first in a short video series that provides an introduction to some MATLAB fundamentals. This video series is intended for new MATLAB users who already have some programming background and who are fairly proficient at linear algebra and matrix operations. MATLAB is a powerful software package which is generally used for technical computing. MATLAB is short for Matrix Laboratory. It's optimized for performing mathematical operations on matrices and arrays. So efficient use of MATLAB involves setting up your problem in terms of matrix operations. If you want to purchase MATLAB, it's available from the MathWorks website. If you're a student, an inexpensive but fully featured student version is available. Octave and Scilab are free software packages which emulate MATLAB's capabilities. Most of the commands I'll introduce in this video will work just fine in Octave and Scilab. My preference is to use MATLAB for reasons that probably aren't worthwhile going into here. I urge you to try them all and form your own opinions. In this video, the first thing I'll do is provide a very brief introduction to the MATLAB user interface. Terms you want to make a note of and remember are the desktop, the command window, and the workspace. Let's get that over with right now before we proceed with the main topics of this video. When you first open MATLAB, you'll see what's called the desktop. The desktop has a variety of icons and windows, but the only one that's really important to us for the moment is the command window, this large white window in the center of the desktop. The command window is where you type commands that you want MATLAB to execute. Commands are typed at the command prompt, these two greater than signs here. For example, I can ask MATLAB to perform mathematical operations like dividing 22 by 7 by typing 22/7 at the command prompt. When I press the Enter key, MATLAB evaluates the expression and returns the result. Notice that MATLAB has named my result ANS, which is short for answer. MATLAB's also saved the result of my calculation in a section of memory called the workspace. To see the variables in the workspace, you can type who at the command prompt and press the Enter key on the keyboard. To see additional information about the variables, you can use the whos command. That's really about all we need to know for now. I'll do almost all my work by typing commands at the command prompt. There are graphical user interfaces on the desktop to do some of these same things. I encourage you to explore these tools and decide whether you prefer to use them to the command window. The bulk of this video will be about creating arrays. This is an important topic since arrays and array operations are fundamental to using MATLAB. As I talk about creating arrays, I'll also introduce MATLAB's rules for naming variables. There are several different ways to create arrays using MATLAB. The first approach I'll introduce is to explicitly list the elements that are going to be in the array. This approach can be tedious for large arrays, so it's common to use what's called colon notation to create arrays whose elements follow some pattern. Finally, I'll introduce a few MATLAB built-in functions that create arrays. Arrays are groups or sets of numbers. That is, a given variable can contain many numbers. For example, this array, A, contains 9 numbers organized in 3 rows and 3 columns. The array X has a single row with 3 numbers in it. This array, Y, contains a single column also with 3 numbers. Individual numbers in the arrays are typically specified by the row and column in which they can be found. For example, the element of A in the second row and the third column is 3. This element would typically be referred to in mathematical notation with subscripts as A of 2, 3, row column. This has the value 3. The second element of X, X2, would be 2. And the third element of Y, Y sub 3, would be -6. Creating arrays in MATLAB can be done in a variety of ways. The first approach I'll present is to create the array by individually specifying every element in the array. To specify that the values being typed belong in an array, enclose the values in square brackets. By default, the first value that you specify will be in the first row and first column of the array. Subsequent to this, successive columns are separated by either spaces or commas. Successive rows are separated by either semicolons or by pressing the Enter key on your keyboard. All variables that you create in MATLAB must be assigned a name. The variable name is placed to the left of an assignment operator, which looks like an equal sign, and the values in the array are placed to the right of the equal sign. This probably makes more sense in terms of some examples. The first thing I'll do is create a two-dimensional array, B, as shown here. To create this array, type the variable name, B, an assignment operator, and then an open square bracket to let MATLAB know that the values in the array are coming up. The first thing I put in is the first element in the first row. 1, I put a space or a comma to separate the next column over. A 2, a semicolon is used to move down to the next row. I type 3 and 4 separated by either spaces or commas. Another semicolon moves me down to the third row, and I type 5 and 6. Closing the square brackets indicates to MATLAB that I'm done defining this array. Pressing the Enter key now will assign these values to this variable. Now let's do some other examples using MATLAB directly. First, I'll define a two-dimensional matrix named A. Type the variable name A, an equal sign, an open square bracket, then 1 space 2 space 3, a semicolon to move down to the next row, 2, I'll use a comma here, 5, comma 6, another semicolon to go down to a third row, 7 space space 8, comma 9, close the square brackets, and press Enter. Notice that the commas can be used interchangeably with spaces to separate columns. Now let's create a row vector by defining B equals, open square bracket, 1 space 3 space 2 space 6 space 7, close square brackets. Finally, I can create a column vector, C equals 4 semicolon 5 semicolon 6 semicolon 8. You can also use the Enter key to separate rows. For example, I can create a matrix D equals, open square bracket, 0 space 1 space 0, Enter 2 space 1 space 3, close square brackets. In this case, MATLAB doesn't execute any commands as a result of pressing the Enter key when I was defining the matrix, since we haven't closed the square brackets yet, and MATLAB knows that we're not done defining an array. Scalars can be defined as an array containing a single number. So x equals square bracket 4, close square bracket. In MATLAB, scalars are simply a special case of an array. However, if we are defining a scalar, the square brackets are optional. Typing y equals 7 works perfectly well. Now let's take another look at the contents of the workspace with the whos command. Now, if you need to redo a command, a simple way to do that is to press the up arrow on your keyboard. The command prompt will cycle backwards through the previous commands you've executed. You can pick the one you want, edit it, and re-execute it. Since any array we define requires a name, let's quickly summarize MATLAB's rules for naming variables. Variable names can be at most 63 characters long. You can try to create variable names with more than 63 characters if you want to, but MATLAB simply removes any characters after the first 63. Variable names should start with a letter. Other characters can be any combination of letters, numbers, or underscore characters. Variable names cannot contain spaces, punctuation, mathematical operators, or most other special characters like %, $, and so on. Variable names are case sensitive. Capital versus lowercase letters do make a difference in your names. There are some words that, even though they meet the above rules, are not allowable variable names. These are what are called reserved words, and they have special meaning to MATLAB. If you try to use a reserved word in a variable, MATLAB will give you an error message. If you're interested, you can list the reserved words by typing is keyword at the command prompt and pressing Enter. MATLAB has a lot of built-in functions. function names can be assigned as variables. Now let's do some demos of what I'm talking about here. First, let's see a list of the reserved words by typing is keyword at the command prompt and pressing enter. A lot of these words will look familiar to you if you have some programming experience. None of the words on this list can be used as variable names. For example, if I try to assign the value 4 to a variable named while, MATLAB gives me an error message. Notice though that MATLAB's function names don't appear on this list. You can redefine function names as variables. For example, the function sin takes the sine of an angle given in radians. So sin, open parentheses, pi/4, close parentheses, where pi is MATLAB's built-in variable pi, returns 1 over root 2. If I want to, though, I can define sine as a number, say 5. Now if I try to take the sine of pi over 4, I get an error. It's interpreting sine as the name of an array and is trying to find the pi over 4th element of the array. Elements in arrays are addressed by the row and column of the element, and we don't have a pi over 4th row or column in the number 5. Having said that, let's talk about array element addressing next. As with our previous mathematical array notation, the elements in an array in MATLAB are specified by the row and column numbers in that order of the element. However, in MATLAB, instead of using subscripts, we place the row and column numbers in parentheses after the array name. The row and column numbers must be separated by a comma. Numbering of rows and columns in MATLAB always starts with 1. This is a little different than some other programming languages. C, for example, uses the first element in an array as the 0th element. Elements of a one-dimensional array can be addressed by a single number. If the array has a single column, you use the row number. If the array has a single row, use the column number. Let's walk through a couple of examples here first, and then we'll do some demonstrations using MATLAB. First, suppose that we have this array already created in the workspace. I can extract the element of B that's in the 3rd row and the 2nd column, this 6, by using this notation, B of the 3rd row, 2nd column. This becomes a 6. I use the assignment operator to assign that number to C, so this sets C to 6. I can also assign values to specific locations in the array as well. For example, I can assign the number 7 to the element of B that's at the 2nd row and the 2nd column. This puts a 7 in this location here, replacing what was previously at that location. All the other elements of the array are unaffected though. Finally, let's see what happens when we assign a value to an array location that doesn't exist. For example, let's assign the number 9 to the element of B that's at the 3rd row and the 3rd column. B doesn't have 3 columns, so MATLAB creates that location by placing another 3rd column in B, and it puts 9 at this location. It can't leave the other 2 elements that it created empty though, so MATLAB fills these guys with zeros. Our workspace has gotten kind of crowded with junk. So before I do anything else, I'm going to get rid of all my previous variables. The command clear space all clears all the variables out of the workspace. Let's check that with the who command. No variables are listed now. If you just want to remove specific variables, the command clear a space and a list of the variables you want to remove takes care of that. Be careful though. Clear by itself clears all the variables from the workspace the same way the clear all command does. Now let's create a couple of vectors. We'll set x equal to 1 space 2 space 3 space 4 and y equals -3 semicolon -2 semicolon 1 semicolon 0. The third element of y can be retrieved by typing y of 3. The second element of x can be obtained by typing x of 2. Notice that we can access elements of one-dimensional arrays with a single index. We don't need to keep track of whether the array is a row or a column. MATLAB does that for us. However, if we do want to use two indices, we can still get the second element of x with the command x of 1, 2. The elements in the first row, there's only one row in x, and the second column. We can add an element to y by typing y of 3, 4 equals 7. MATLAB increases the size of the array as necessary and puts a 7 in the correct location, filling zeros in for all the unknown points. We can streamline our approach to both matrix creation and accessing array elements if there's a pattern to the elements we're creating or the elements we want to access. Both of these approaches use colons to specify the values we're interested in. First, we'll look at creating arrays using colon notation. The general syntax is that we specify a starting value, a number that we start at, an increment between elements, and an ending value, or more accurately, a value that we won't exceed when we're creating the array. So when the array is created, the first element is always the value specified as start_val. Subsequent elements in the array are created by adding the value specified by increment to the previous element in the array. MATLAB ends creation of the array when the next value exceeds the value specified by end_val. This is probably most easily explained in terms of an example. So if we use syntax like this to create an array x, it specifies a starting value of 0.2, an increment of 0.3, and an ending value of 0.9. The array gets set up. It starts with a value 0.2, listed here. The next element in the array is created by taking the increment, 0.3, adding it to the previous element, which gives me 0.5. The next element takes the previous value, 0.5, adds the increment, 0.3, to it, and comes up with 0.8. The next element that would be created would be 0.8 plus 0.3, which would be 1.1. That's bigger than the final value that's specified, so MATLAB stops creating the array, and we end up with these three numbers in the array. We can also access ranges of elements in an array with colon notation. The approach is similar to that taken when creating arrays, but the numbers created appear within parentheses after the variable name. And, of course, all of these have to be integers because they're being used as array locations. We specify a beginning value, start_ind, an increment, and a final value, end_ind. The actual indices are calculated the same way they were on the previous slide. The first index in the list is start_ind. Subsequent indices are created by adding the increment to the previous index. The command stops creating indices when the next value in the sequence exceeds the final value specified by end_ind. Now, a colon by itself returns all elements in that dimension of the array. Also, if you don't specify an increment, MATLAB will count by ones. First, I'll do a couple of examples on this whiteboard to see how this works, and then we'll do some more demos using MATLAB. This is the matrix we're going to be working with. My first example is to use this syntax. I'm specifying a series of rows and a series of columns. They're in the parentheses, they're in row column order, and they're separated by a comma. The first row is going to be row 1. I'll get my next row by adding the increment 2 to 1 to get 3, so my next row will be the third one. The pattern for the columns is the same. The first column is column number 1. The second column is going to be column number 1 plus 2, which is 3. And this is going to access these elements that have these combinations of row and column numbers. So C, when all is said and done, is going to be 1, 0, 5, 9. Let's do one more example. If I say b of 1 to 2, the first row that I'm going to access is row 1. I haven't specified an increment, so it's going to count by ones. The second row I'm going to get is going to be this row plus 1, which is row 2. If I kept on going, I'd get to row 3, but that's bigger than the maximum value that I've specified, which is row 2. I'm going to pick up the first 2 rows here. The colon here in the columns just means that it's going to take all of the columns in these rows, so I'll get those 6 numbers, and D will be 1, 2, 0, 3, 7, 0. To start out, let's create a fairly large vector, starting at 0, incrementing by 0.1, and ending at 10. There are 101 points in the vector, and they scroll by pretty fast. Watching them do that isn't really very productive. But we can keep the results from being displayed on the screen if we choose. Just terminate the command with a semicolon, and display of the output of the command is suppressed. Let's create another large array by typing big array equals 0, 0.01, 100, followed by a semicolon, and then pressing enter. The variable big array is created, and it is in our workspace for later use, but we don't need to look at the numbers. We can also use colon notation to access specific elements of an array. For example, let's just extract the even elements of our z vector and call the result z underscore even. Z underscore even equals z of, I'm going to start at the second element, increment by 2, and go to the last element by typing end, end. End is an easy way to get the address of the last element in an array in any dimension. Our new array contains the second, fourth, sixth, and so on elements of the original array. Finally, let's take a look at some MATLAB commands which create arrays for us. I'll give you a pretty short list here with very few details as to how they're going to be used. But if you know the command name, it's easy to find the appropriate syntax and how the command works using MATLAB's help files. The command linspace creates an array of linearly spaced elements. They're uniformly spaced. It's very similar to the colon notation to create arrays. Logspace creates an array of logarithmically spaced points. Zeros creates an array that's full of zeros. You give it the number of rows and columns you want. It creates an array of that size and it fills it with zeros. Ones works essentially the same way, except that it fills the array with ones. EYE creates an identity matrix. It works very similar to zeros and ones. Rand and randn create arrays of random numbers. Rand creates uniformly distributed random numbers. Randn creates normally distributed random numbers. Finally, again, to know how to use these and get full instructions on how they're employed, use MATLAB's help files. Before we do anything else, let's take a look at how to access MATLAB's help files. If you know the name of the command that you want information about, type doc, a space, and the name of the command. For example, to get help about the rand function, type doc, space, rand, and press enter. A help window opens and a page is displayed which tells you all about the rand function. At the top of the page, a list of ways to invoke the command are provided. Most of the rest of the page is devoted to explaining these approaches, including some examples. A nice feature is that at the bottom of the page there's a list of other functions that are related to the function you're getting help on. If you type doc with no function name, the basic help window opens. From here it's easy to browse the help files or search for information. You can also display help information directly in the command window with the help command. Type help, space, and the function name, for example, rand. You can also search for information directly in the command window. The appropriate command is look for. Type look for, a space, and a string containing the information you want to find. For example, look for, space, a single quote, integral, close single quote, provides information relative to integration. Now let's use the rand command to create a 10 by 10 array of uniformly distributed random numbers. I'll type rand underscore stuff equals rand of 10 comma 10, the number of rows and the number of columns. Just as practice with using colon notation to extract a full row or column of an array, I'll display the second column of rand underscore stuff by typing rand underscore stuff of colon for all the rows, comma 2 for the second column, and pressing enter. There's another array creation function that's kind of fun. The magic function creates what's called a magic square of numbers. Typing funmat equals magic of 5 creates a 5 by 5 magic square. An interesting property of this matrix is that each row or column sums up to the same number. To check this out, let's use MATLAB's sum command. The sum command will add up all the elements in any row or column vector that's sent to it. To sum the elements in the first row, I can type sum of funmat of 1 for the first row, comma, quote for all the columns, close parentheses, close second parentheses. We get 65. Now let's sum the elements in the third row by typing sum of funmat of 3, comma, colon. I get 65 again. The sum of the elements in the fifth column can be found by typing sum of funmat colon for all the rows, comma 5 for the fifth column. The result is again 65. We've covered a lot of ground in this video, so let's do a quick summary of the main points. First, we did a really brief introduction to the MATLAB desktop. The only really immediately important information about the desktop was the command window, where commands are typed at the command prompt, and the workspace, where the results of our commands and calculations are stored. We also talked about creating variables and the rules for naming our variables. The main focus of this video, however, was arrays. Arrays are super important if you want to use MATLAB effectively. We talked about several ways to create arrays. We created them by specifying individual elements, by using colon notation, and by using some built-in functions. We also talked about addressing specific elements of an array by explicitly providing row and column numbers or by using colon notation. Finally, we talked a little bit about MATLAB's help documentation. It's important to be able to use MATLAB's documentation effectively. There are literally thousands of MATLAB commands, almost all of which can be used in multiple ways. There's no way anyone can remember all the uses of all these functions. You need to be able to look up the commands to remind yourself how to use them. We also introduced some handy MATLAB tips. A semicolon following a command suppresses displaying the results of that command. The clear command can be used to remove variables from your workspace. Who and whos show the variables that are in the workspace, and with whos some of the properties of those variables. MATLAB has a number of predefined variables. We used pi. A few others are I and j, which are the square root of -1, nan, which is an undefined number, and inf, which is MATLAB's version of infinity. End can be used to provide the index of the final element in an array. Finally, we use just a couple of MATLAB's built-in functions. Sum to add up the elements of an array, and sine to take the sine of an angle. In our next video, we'll start using MATLAB to perform mathematical operations. We'll talk about MATLAB's arithmetic operators and some more of the built-in MATLAB mathematical functions.